derivative test. All right, so the first derivative test, assume you have a critical point x equals c for the function f of x. If f prime of x changes sign at x equals c, then x equals c is an extrema. If the sign of f prime of x, changes from positive to negative at x equals c, then x equals c is a max. If the sign of f prime of x changes from negative to positive at x equals c, then x equals c is a minimum. So let's look at an example. F of x equals x cubed. So the first thing we have to do, step one, is we have to get f prime. So f prime of x would be, let's see, it's x cubed, so it would be 3x squared. All right, step two, we got to get the criticals. All right. Okay, get the criticals. So f prime of x, there's no place that it does not exist, so all we have to worry about is where f prime equals 0. So take 3x squared, set it equal to 0. Solve for x, divide both sides by 3. So x squared equals, 0. Take the square root of both sides, so x is just 0. So that's our critical value. Now what we want to do is test it. All right, so let's draw out a number line. All right, let's give it some arrows. You want to plot your critical points, in this case just 0. I'm going to put a star above the critical point. Now what you want to do is you want to test a point to either side. All right, I don't know what it did there. I don't know why I did that. Okay, I guess another version of Smart Notebook is starting up. All right, so let me go back down. So get the criticals. We got the criticals. So now what we're going to do is we're going to test a point to either side. Let's test -1 and +1. All right, so we put in -1 into our value. Into our function. We get 3 times -1 squared. -1 squared is 1. 3 times 1 and 1, this is positive. All right. Plug in 0, you get 0. So it's, all right. Plug in 1, you get 3 again, so it's still positive. So as you can see here, on this interval, it's increasing. All right. On this interval, it kind of took a break because the slope's 0, so it took a little break. It got tired of increasing. But then once you pass 0, it is still increasing. So what does that tell you? That tells you that x equals 0 is absolutely what? Nothing. That means this graph has no extrema. All right, and if you remember what the graph of x cubed looks like, it is simply that right there. The slope of the tangent line is always going to be positive, because if you put a negative in here, you end up squaring it anyway, so you're multiplying 3 by a positive number. So the slopes of all the lines tangent here will always have a positive slope. When they get here, they'll have a 0 slope, but the thing is to remember is that it has to change from a positive to a negative or a negative to a positive. Here it's positive, goes to 0, stays positive. So therefore, in this case, x is absolutely nothing. All right. And there's also no endpoints that we have to consider, all right, because they didn't restrict anything. So we don't have to worry about f prime being does not exist. And we also don't have to worry about endpoints because they did not give us an interval. All right, they didn't say, comma, it has to be in that interval. They did not give us an interval, so we don't have endpoints, and there's no place this graph is undefined, so we don't have to worry about does not exist case. All right, let's look at another example. F of x equals 1/2 x minus sine x. Use the first derivative test to find mins and maxes. So first step, we have to get f prime of x. Well, f prime of x is going to be, that's going to be 1/2. Derivative of minus sine is minus cosine x. So there's our derivative. Step 2, we have to get the criticals. All right, get the criticals. Well, we don't have to worry about it, does not exist in this case. And we don't have any endpoints. So we simply solve it out. All right, 1/2 minus cosine of x equals 0. In this case, I'm going to add cosine of x to both sides. So 1/2 equals cosine of x. So now what you simply do is you have to remember where your cosine equals a positive 1/2. All right, if you remember, all students take calculus, so it's positive in this quadrant and in this quadrant. So we just have to figure out what angle it is. And if you remember, it should be pi over 3, which means all the way around would be 5 pi over 3. So there's our two critical points. All right, so our two critical points are x equals pi over 3 and 5 pi over 3. All right, so step 3 is the number line step. All right, so draw out your number line and plot your two critical points. All right, so let's put pi over 3 here, 5 pi over 3 here. Now what we want to do is we want to get a point on this side of pi over 3. I'm going to star the criticals so we can keep them separated. So let's put 0 here. We need to find a point between them. Doesn't matter if it's exactly between them or not, as long as it's between them. So let's pick pi. And then we got to get a point on the other side of pi, 5 pi over 3. So let's use 2 pi. All right. So now if you plug these in, all right, you got to plug these into here. If you plug in pi over 3, all right, you're going to get, I'm sorry, if you plug in 0, 1/2 minus the cosine of 0, which is 1, you're going to get a negative number. All right, you plug in pi over 3, you're going to get, of course, this is 0, I'm sorry, this is 1/2, so 1/2 minus 1/2 is 0. All right, and again, if plug in here too as well, this is 1/2, so you're going to get 0 again as well. Plug in pi, 1/2 minus the cosine of pi will give you a positive number. Put in 2 pi, 1/2 minus the cosine of 2 pi will give you a negative number. All right, so since it goes from negative to positive, that means that this is a min. And since the slopes here are negative, that means this function is decreasing here. All right, since these are positive, that means it is increasing. And since it goes from positive to negative at 5 pi over 3, we know this is a max. And since all these are negative, this is decreasing on that interval. All right. So we know that pi over 3 is a min, and 5 pi over 3 is a max. All right. That's why you do the number line. Okay. Remember, at the critical points, your slope is going to be 0 in this case. All right, so then you plug in 0 into f prime of x, you get a negative number, so it's decreasing. You plug in pi, you get a positive number, it's increasing. Since at the critical point it changes from a negative to a positive, that means it's a min. We plugged in 2 pi as well, and we got negative. And since it goes from positive to negative at the critical point, 5 pi over 3, we know that is a max. All right. Now I want you to try one. All right, well, let me say one more thing. So our interval where it's increasing, all right, it is increasing from pi over 3 to 5 pi over 3. and it is decreasing from negative infinity to pi over 3, and from 5 pi over 3 to positive infinity. All right, so there's our intervals, and then this is a min, and this is a max. So now I want you to try one. If f of x is x to the fourth plus x squared minus 2, find the interval for which f is increasing. So pause the video, take a few minutes, figure it out. All right, so step one, you got to get the derivative. Step one, get f prime of x. So that's going to be 4x cubed plus 2x, and then the minus 2 just kind of goes away. So here is our f prime. Apparently I can't spell. Step two, we want to get our criticals. There, I about did it again. Step two, get criticals. All right, so we want it, so we don't have to worry about does not exist. We don't have to worry about endpoints. So all we have to do is set f prime of x equal to 0. So 4x squared cubed plus 2x equals 0. You can divide both sides by 2 to get 2x cubed plus x equals 0. Factor out an x, 2x squared plus 1 equals 0. So x can equal 0, or 2x squared plus 1 equals 0. Subtract the 1 from both sides. 2x squared equals negative 1. Divide 2, divide 2. X squared equals negative 1/2. Take the square root. Well, x equals positive or negative square root of negative 1/2. Since that's not real, we can throw it away. So our only critical value here is x equals 0 because that was not a real number. All right, not real, so we don't have to worry about it. Now, step 3 is to draw your number line. All right, and plot your critical value. So here we go. Number line, put 0 in the middle. Let's put negative 1 on this side, positive 1 on this side. Let me star the critical point so we can keep up with it. Now plug in negative 1 into here. You get 4 times negative 1, which is negative 4, minus 2, which is minus 6. So you get a negative number on this side. Plug in 1. You get 4 times 1 is 4, plus 2, which is 6. So you get a positive number on this side. All right, so since it goes from negative to positive, we know 0 is a min, and we know that since these are negative, it is decreasing on this side, and since this is a positive, we know it is increasing on this side. So our interval for increasing is going to be 0 to positive infinity. And this is actually the answer to the question that was asked, because it says find the interval for which f is increasing. The interval for which f is increasing is 0 to positive infinity. Okay, and 0 was a min. All right, so make sure you are answering the question at hand, because if you would have told me on a test that 0 was a minimum, I would have said good job, but that's not what I asked. All right, so make sure this one said find the interval. The interval is 0 to infinity. All right, so there's no ticket in the door for this one, and make sure you know how to do this before you come to class tomorrow. You can rewatch this video as always as many times as you need to make sure you fully understand this. All right, see you tomorrow.